Hi everyone, this is the video notes for lesson 5.3 on trig, sine, cosine, and tangent. So let's define what the trig functions are first, and then we will use them to find sides of right triangles. So before we start though, you're going to need a scientific calculator, one that has the buttons with sine, cosine, and tangent on them, and obviously some highlighters because I did some highlighting. So if we start, the trig functions are defined as the ratios of the sides of right triangles. So we have to have a right triangle, and then each function represents a different ratio of those sides. So sine is the ratio of the opposite side from where our angle is, and we use theta to represent our angle. So that's what that is. It's a Greek letter, theta. So sine is the opposite side divided by the hypotenuse. So in our picture, we need to figure out what is the opposite and what is the hypotenuse. So we know from before that opposite of the right angle is the hypotenuse. And then the opposite side would represent this side over here, the side that's opposite of wherever our angle is. So I turned my picture where my right angle was down in the bottom right corner, but if we were up here, then our opposite side would be located in a different position. The hypotenuse is always the side across from the right angle though. Okay, so if we look at our triangle up in the corner, it says to find the sine of angle A. So remember, sine is opposite side over the hypotenuse. So opposite of angle A would be 4. And the hypotenuse is the side across from the 90, so that would be 5. If we did the same thing, but from side B, opposite of side B is 3, and the hypotenuse would still be 5. Cosine is defined as the adjacent side over the hypotenuse. So for cosine, we're still using the hypotenuse. So for our picture, hypotenuse, side across from 90. This time the adjacent side is the other side that's touching that theta, where our theta is. So the side that forms that angle. So this would be our adjacent side. This is the opposite, but we're not using that for cosine. So the cosine of angle A would be the side that's adjacent to angle A over the hypotenuse. So adjacent over the hypotenuse. So what is the cosine from angle B? I know I just said the adjacent and I wrote the opposite. Adjacent to A is 3. Sorry. Okay, so what is the cosine of angle B? Very good. Adjacent is 4. Hypotenuse stays the same at 5. You notice a pattern with our sine values and our cosine values and what happens? We're going to talk more about that in class. So our last one is tangent, and tangent doesn't use the hypotenuse at all. Tangent is the opposite side over the adjacent side. So the opposite of angle A is 4, adjacent is 3. So what would be the tangent from angle B? Very good. Opposite is 3, adjacent is 4 to angle B. So it might be kind of hard to remember which one goes with what. So we have this mnemonic to help us. So sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over adjacent. So that's where those letters come from because they help us remember. T-O-A, tangent is opposite over adjacent. So we pronounce that SOHCAHTOA, and that's how we can use that to remember. Another thing, if you needed to come up with ways to remember the letters, if you can't remember the spelling for that, is this saying, some old hippie came a-hopping through our apartment. So that would be sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So those are just two different ways to help you remember which side ratios go with which trig function. So let's use those sides ratios to help us find sides of triangles. Okay, so there's some steps at the top. If you're getting confused or you don't know what to do or you like reading it, go ahead and read those steps. I'm just going to jump right in though. Okay, so to find any side that we're missing, we first need to figure out, do we have opposite, adjacent, or hypotenuse? Okay, so find your angle. That's our theta. I always start by finding the hypotenuse because that's the easiest. It's across from the right angle. Then I find the adjacent because that's across from the angle that we're given, or then I find the opposite. Opposite is across from the angle that we're given. So that would leave the last side, the one that's touching the angle, to be the adjacent side. So I know that we labeled all three, but not all three had values on them. So what I'd like to do is cross out the one that had nothing on that side, so that way we know which sides we have left to write our ratio. So we have the opposite side and the adjacent side. So which trig function used the opposite side and the adjacent side? Very good, tangent. Okay, so the formula said that the tangent of our angle theta is equal to the opposite side divided by the adjacent side. So now that we have our formula written out, we can just plug in what we know and find the value of the one that we don't know. So we know our theta is 64. So tangent of 64 equals side opposite, which is x, divided by adjacent, which is 9. So from there, we just have to solve to get x by itself and then type it in our calculator to get the value for x. So to get rid of that 9 in the denominator, since it's being divided, the opposite of division is multiplication. So we would times both sides by 9, and that's going to cancel out the 9 in the denominator. So we would have 9 times tangent of 64 is equal to x. So this is where your calculator comes in. So if there's two different kinds of calculators and the ways that you can type them in. If you have one of these kind of scientific calculators, or there's a lot of other ones that are similar to this, it's like a regular calculator. So all you would have to do is type it exactly what it says, 9 times the tangent of 64. Sometimes you have to close that parenthesis, but most of them, like this one, you don't have to. And then you get the decimal approximation. So what this is telling us is that this side is approximately 18.45. So we found the length of that side by typing that in. So I'm going to use the approximately symbol since we're rounding. So I rounded to 2 decimal places this time. Sometimes I might ask you for the thousandth or the tenth. It just depends. For your notes, I'm rounding to 2. Okay, so if you type that in your calculator the way I just showed you and it did not come out to be 18.45, that means you have what I call a backwards calculator. And this is an example of a backwards calculator, and it looks just like a scientific calculator, so you don't know that it is backwards, like unless you type things in. So the way that I know is if I hit cosine and it comes out to 1, or as opposed to this, if you hit it, it says, well, what angle are you trying to use? Okay, so this one, it took it as the cosine of 0 because that was what number was left in there. So you have to type the angle measure first. So 64 tangent. So that's this part of it. And then the other part is to times by 9. So that's why it's backwards, because you're kind of going backwards. So we start with the angle, then we hit tangent times 9. Okay, so that's a backwards calculator. If you're using a calculator on your cell phone, most of them, I would say like all of them, are probably backwards calculators. Okay, so I'm going to do one that's a little bit different. So I'm going to go down to the next one. Okay, so if we write what side, if we label our sides, across from the 90 is the hypotenuse, across from our theta is the opposite, and then the other side is going to be your adjacent. So we don't have anything on the hypotenuse, so we have tangent again. Okay, so tangent of theta equals opposite over adjacent. So if I plug everything in, we know we have tangent of 28 equals 2 over g. So this one is different than the last one. Why is it different? Very good. This one, our variable is in the denominator, where up here our variable was in the numerator. But we're going to start out our problem exactly the same. To get rid of something in the denominator, we times both sides by what's in the denominator. So that's going to cancel out our g in the denominator. So next we would have g times the tangent 28 is equal to 2. Well, remember our goal when you're solving an equation is to get the variable by itself. Is the variable by itself here? Nope. So what operation connects the variable to that number tangent of 28? Well, it's multiplication. What's the opposite of multiplication? Awesome. You're correct. It is division. So we're going to divide both sides by the tangent of 28. So when you divide something by itself, it always cancels out and equals 1. So that's how those cancel out. So then we end up with g is equal to 2 divided by the tangent of 28. So we'll just type that in our calculator. 2 divided by the tangent of 28. And we get 3.76. Approximately. Make sure you use the approximately sign. Okay, so that's pretty much it. I'm going to show backwards calculator people how to type that in your backwards calculator because it's a little bit different. And then you can pause and try the rest of them. And I will show you the answers in a minute. So for backwards calculator people, we kind of do it the way it says, but then we have to hit the angle first. So we would type 2 divided by, the angle is the backwards part, so the angle of tangent and then equals. Okay, so for the backwards again, that was 2 divided by angle first, then tangent, and then equals. Okay. Okay, so go ahead and pause and solve the rest of them. And when you come back, I will show you the answers. Okay, so for the two up there, we had sine for both of them, and the variable was in the top. So those were kind of like the first one we did. So you just have to times by that number in the denominator and then divide to get your variable. For the next two, we had cosine and then another sine. This one was kind of like the top ones, except you were hitting cosine instead. Okay, this one was where our variable was in the denominator, so first we had a times by x, and then divide by sine. So we get 10 divided by sine of 36, which is approximately 17.1. Okay, so there's your answers for the bottom ones. If you have any questions, make sure you write them down, so that way you remember to ask about them next class. Thank you.